down with new chapter group 17 and this is part 1. Okay, apa yang awak tahu pasal group 17? Apa elemen dalam group 17? So dalam group 17 kita ada chlorine, fluorine, bromine kan, dan iodine. Okey. Kemudian apa lagi yang kita tahu pasal group 17? Group 17 dia prefer untuk receive electron. So bila receive electron it become an ion. So dia jadi chloride ion, fluoride ion, bromide ion and iodide ion. Okey, kenapa elemen ini dia terletak dalam group 17? Okey, because of the electrovalence. So in group 17 dia mesti ada 7 valence electron. Okey, for example for iodine, so iodine for fluorine. So fluorine, the proton number is equal to 9. So kita ada 1s2, 2s2 and 2p5. Okay. Jadi dekat sini kita boleh nampak the valence electron is equal to 7. So all element in group 17 dia ada 7 valence electron. And one more thing yang paling penting, dalam group 17 semua elemen exist as diatomic molecule. Okay, diatomic Cl2, ada 2 atom dalam satu molecule. Okay. Change in the volatility and color intensity of the elements. All the halogens exist as diatomic molecules and they are all color. Okay, ada warna. When going down the group, the melting and boiling point of the element increases. Okay. The van der Waals forces between the molecule increases due to the increases in the size of the molecule. So, bila menuruni kumpulan, size semakin besar. Therefore, the forces between the molecule increases and the melting and boiling point also increases. Thus, the volatility of the halogens decreases when going down the group. Okay, volatility ini ialah dia punya tendensi untuk jadi vapor, volatile. Okay. Okay, we look at the color. So fluorine pale yellow, okay, chlorine green yellow, bromine red brown, and iodine black in solid, violet in gases. Okay, the boiling point we see from fluorine, chlorine, bromine, and iodine, the boiling point increases. Okay, jadi ini membuktikan pernyataan tadilah, bila menuruni kumpulan saiz semakin besar, the van der Waals forces between the molecule increases, therefore the boiling point also increases. When the boiling point increase, the volatility decrease. Okay. So the different colors is due to the absorption of different frequencies of visible light when an electron is promoted from the ground state to a higher state. Okay, masih ingat lagi ground state, higher state? Okay, dalam semester 1 kita dah belajar apa dia ground state, apa dia higher state. Okay, yang 4S, 3D, okay. Bromine, chlorine, yellow, absorb violet light. Bromine, the color is dark brown because it absorbs greenish blue light. And iodine is a violet color because it absorbs red light. Halogen as oxidizing agent. Okay, seperti yang saya bagi tahu sebelum ni di awal video tadi, halogen dia adalah prefer untuk receive electron. So bila dia receive electron, dia akan reduce, okay, akan jadi process reduction and it become oxidizing agent. Okay. So the relative strength of the oxidizing agent can be determined by comparing their standard reduction electrode potential. Okay. Standard reduction electrode potential ni ialah E naught. Here. Okay, E naught. So, kita ada E naught from positive 0.56, then positive 1.07, and another one positive 1.36. Okay. So, bila E naught semakin besar, the oxidizing strength is increases. Okay. Jadi nak tahu dia strong ataupun weak, kita compare dia punya standard reduction electrode potential, E naught dia. Kita compare dia punya E naught untuk menentukan dia punya strength. Okay. The higher the E naught value, the stronger the strength of oxidizing agent. Okay. So kalau kita tengok di sini, chlorine is the stronger. Okay, sebab nilai E naught dia yang paling besar. Okay, the oxidizing strength of a halogen decreases going down the group. This is because the larger the size of the halogen atom, the weaker is its ability to accept electron. Okay, bila size semakin besar, so daya tarikan untuk menarik elektron masuk tu sangat lemah lah. Okay, weak. Jadi sebab tu dia punya oxidizing strength dia semakin rendah. Okay, decrease. More electronegative halogen can displace less electronegative halogen from its halide solution. For example, chlorine can displace bromide ion in potassium bromide, but iodine cannot displace bromide ion in potassium bromide. Okay, kita buat chemical equation untuk bagi dia clear ya. Apa maksud dia? Okay, dalam group 17, first sekali, yang atas sekali kita ada fluorine, followed by chlorine, bromine, and iodine. Okay, so, bila dia kata chlorine can displace, so kita ada Cl2 plus potassium bromide, KBr. Okay, another one we have iodine plus KBr. Okay, so tindak balas ini, dia kata chlorine can displace. Okay, tindak balas ini boleh berlaku di mana produknya kita akan dapat KCl plus Br2. Okay, tapi tindak balas yang kedua ni tidak akan berlaku. Okay, sebab iodine cannot displace bromide ion in potassium bromide. Dia tak boleh nak gantikan bromide ion di sini. Okey, sebab apa? Sebab kedudukan bromine lebih tinggi daripada iodine. Which means, okay, bromine is more electronegative than iodine. So, iodine tak boleh nak displace. Okey, compare dengan chlorine tadi. Okey, chlorine ni, dia more electronegative than bromine. That's why dia boleh displace bromide ion in potassium bromide. Okay, so kita boleh tahu, okay, so daripada sini chlorine, okay, yang di atas, elemen yang di atas is more electronegative than elemen yang di bawah. So bila menuruni kumpulan, dia punya electronegativity is decrease. Okay. Next, hydrogen halide. So hydrogen halide is come from halogen, okay, but in the form of ion. So dia boleh jadi hydrogen chloride, okay, hydrogen bromide, okay. Under suitable conditions, all halogens react with hydrogen to form hydrogen halides, which are colorless gas. Okay, compare dengan tadi, kalau halogen itu ada warna, tapi bila dia react dengan hydrogen gas menjadi hydrogen halide, dia menjadi colorless gas. Okay, ini dia punya chemical equation. Okay, general chemical equation. Okay, kalau dalam soalan awak kena pastikan, kalau soalan dah bagi spesifik element, okay, awak kena use specific chemical equation. Okay, kalau ada X ni ialah general. Okay, X boleh jadi chlorine, boleh jadi bromine, boleh jadi iodine. Okay, jadi tengok soalan. Kalau soalan dah spesifik guna chlorine, so awak terus buat chlorine. Okay, so going down the group, the oxidizing strength decreases, hence the reactivity with hydrogen also decreases. Okay, kita tengok tindak balas yang pertama, fluorine and hydrogen gas. Okay, kita buka, kita campurkan. Okay, sekejap okay. Wow, nampak ada sparkle kan dekat situ. So, fluorine reacts explosively with hydrogen at room temperature even in the dark. Okay. So, this reflect give the high reactivity of fluorine towards hydrogen. Okay, so ini tindak balas dia. So fluorine boleh bertindak balas. Okay, kita put sini dark. Okay, dalam gelap pun dia boleh bertindak balas. Okay, next dengan chlorine. So chlorine reacts with hydrogen. Okay, kita tengok tak ada tindak balas. Okay, okay, kita buka tingkap tu bagi sumber cahaya. So no reaction occurs in the dark at room temperature. Okay, that's why chlorine reacts with hydrogen in diffuse sunlight. Okay, and explosive occurs if the gaseous mixture is exposed to sunlight. A moderate reaction occurs if a stream of hydrogen gas is burned in chlorine. Okay, jadi kita gunakan sunlight tapi diffuse sunlight lah. Okay, bukan direct. Okay, next we have bromine and hydrogen. Okay, kita tengok bromine dengan hydrogen tak ada tindak balas walaupun dah ada cahaya. Okay, so bromine does not react with hydrogen in sunlight. Bromine reacts with hydrogen at 300 degrees Celsius in the presence of a platinum. Okay, so there is no reaction occurs even when the gaseous mixture is exposed to sunlight. Okay, jadi kita kena ada catalyst. Okay, kita boleh gunakan platinum or nickel as catalyst. Okay. Same goes to iodine. Dia pun sama. Tak ada tindak balas when it exposed to sunlight. So, dia kena ada catalyst. Okay. At 300 degrees Celsius with platinum or nickel catalyst. But for iodine, the reaction is not complete and partially. Okay. So, due to the weak hydrogen iodide bond, some of the hydrogen iodide molecules dissociate. Okay, jadi bila dia dah jadi Hi tu, dia boleh dissociate menjadi hydrogen gas and iodine gas. Okay, sebab dia reaction dia adalah partially. Okay. So from this reaction, we can conclude that the relative reactivity is in order of, okay, fluorine gas, chlorine gas, bromine gas, and iodine gas. Means when you going down the group, the reactivity is slow. Okay, it decreases. Okay, when you going down the group, the reactivity decreases. Okay, next is the thermal stability of HS, hydrogen halide. Okay, kita nak tengok dia punya stability of hydrogen halide. Okay, kita ada fluorine, chlorine, bromine, iodine dekat bond energy and bond length. So, for bond length, here is the halogen and the grey color here is hydrogen. Okay, this one is halogen, this one is hydrogen. Okay, so ini yang kita nak tengok. Okay, kita akan gerakkan from fluorine. Okay, move to chlorine. You can see the size, okay, become larger. So when the size become larger, the bond energy is decreases. Okay, the bond length, when you going from fluorine to iodine, the bond length is increases. Okay, dia punya bond length semakin panjang. Okay, but the bond energy become decrease. Okay, sebab tadilah bila bond dah panjang, dia punya attraction pun weak. Okay, jadi dia senang untuk dissociate. So, all the hydrogen halides decomposes to hydrogen and halogen gases when heated under suitable conditions. So, the thermal stability of the hydrogen halide decreases in the order HF, HCl, HBr, Hi. This is because the H covalent bond become increasingly longer and weaker. Okay, dia punya bond length tadi ya. Due to the weaker covalent bond, the Hi easily decomposes compared to HCl. Okay. Okay, so kita ada soalan. Okay, STPM 2009. X is an element in group 17 of the predictable. The percentage dissociation of hydrogen halide HS at 2000 degrees Celsius is shown in the table below. Okay, which statement explains the thermal stability of HX on descending the group? So, kita tahu thermal stability of HX bila menuruni kumpulan adalah decreases. Okay, the thermal stability decreases. Okay, so ini semua ada kaitan dengan apa? Okay, relative molecular mass. Jawapan betul tapi tak tepat ya. Okay, the length of the ni, yes. Okay, so ini baru je kita bincang tadi, di mana bila bond length semakin panjang, dia punya attraction semakin lemah, weak. Okay, that's why dia easily dissociate. Okay, jadi jawapan dia adalah B. Okay. So that's all for part 1. Okay, thank you and see you in the next part. Bye.